All right, here we go. Unit 4, Algebra 2, test review. Algebra 2A. A rectangle has this area, has the length of x plus 2 inches. What's the width? Remember, length times width equals area, so what we're really asking is what times this gives us this. In other words, how many times does this go into this? So, one thing I'm looking at here is that this can be factored. So, I'm going to take an x out, and I'd be left with x squared minus 5x minus 14. Under further investigation, that can continue to minus 7 and plus 2. And then we divide by this, and we can see, factor, our width has to be x times x minus 7. A different way you could do this is put the 0 in the chipmunk nest. Take your 1, your negative 5, your negative 14, and then your 0, because there's no constant, and see what happens. Drop the 1, multiply, and this is what we'd get. We drop down 1 from here, so that'd be x squared minus 7x. Same thing as this if we distributed it through. There's number 1. Number 2. First thing we should do is look at the denominators and say x cannot equal negative 2 and x cannot equal 0. Because if we get those as our answers later on, we know that they can't be possible. So we're going to multiply by the biggest denominator. I'll put the x there. Distribute here, and they cancel. So I'm left with negative 1 equals. But then when I hit this, only the x's cancel. So I'd have x plus 2 times 4, which is 4x plus 8. And if I take all of that and I hit this, now the x plus 2 is gone. I'm left with x times 3, 3x. Now it's pretty easy to simplify. I'm going to subtract 8. 7x is negative 9. Divide by 7. Divide by 7. X is negative 9/7, which neither of these are those, so that's my answer. Number 3. What's the resulting equation function if the graph x times y equals 8 is translated up 3 and right 4? Well, the first thing we're going to do is solve for y by dividing both sides by x. Y equals 8 over our x. There's our reciprocal function. So how do we make this move up 3, add 3, right 4, minus 4? And that would be my resulting function. This one, find the slope of the line containing these 2 points using that formula. So here's x1, y1, x2, y2. Plug it in. 1 over x minus 1 over y all over x2 minus x1. Now we have a problem up here because we have fractions, so I need common denominators, which is going to be xy. So I'm going to multiply that by y, that by y, that by x, that by x. So I'd get y over xy minus x over xy equals y minus x all over xy. But that's all over y minus x, which is the same thing as y minus x over 1. So now I'm dividing a fraction by a fraction. So I take this bottom one, flip it, and multiply. And then these cross reduce, swoosh, I'd be left with 1 over xy. There's my answer. Number 5, find the difference. Well, to subtract fractions, we need common denominators. So I'm going to factor this difference of 2 squares, jumps out at me. And I see what my common denominator is going to be. It's going to be this. So I got to add an x plus 8 to the bottom, which means I got to add an x plus 8 to the top. I'm going to do the subtraction later. So I have 4x minus 3 over x minus 8, x plus 8, minus, now I'm going to FOIL this out, so I get x, I'll write it right here, x squared, now I'm going to go outside inside, 8x minus 2x is 6x, minus 16, all over x minus 8, x plus 8. Now this minus, add up through the top. Now that I have common denominators, I know my answer is going to be something over my common denominator. Now I look for like terms in the numerator. I see I only have one little negative x squared by itself. Negative 6x and 4x is negative 2x. 16 and negative 3 is 13. And that will not be factored, so that is our final answer. Find the sum. Again, we got to find common denominators, and this one looks like we can factor it, so let's do it. Notice we now have common denominators, so we can go ahead. We know that that's going to be our common denominator, and we add stuff in the numerator. 4x and 3x is 7x, negative 5 and negative 1 is negative 6. Non-factorable, so we're done. This one straight up gives you common denominators, so no worries. Just add the numerators, done. Find the quotient, means divide, means we got to flip this, so it's going to be x plus 5 over x plus 3 times whatever we get after we get done factoring this. So I can see it's a gotta one, so x and x, two factors of negative 27 up to negative 6, negative 9, and 3. This one, x and x, plus 5, minus 1. I can see these cancel, and these cancel, so I'm left with x minus 9 all over x minus 1. And remember, you can't cross these out, because add ends, bad ends. Number 9. Says find the product. Factor, factor, hector, hector. Difference of two squares there. Factor it. We got a gotta one. So x and x, two factors of negative 16 that add up to 6, plus 8 minus 2. Now we got to factor this one. X and x, two factors of negative 24 that add up to 5 would be plus 8 minus 3. Take a 5 out, we'd be left with x minus 5. Now we're looking for things to cancel. And what do we got left? X plus 5, x minus 3, don't forget about that little 5, x minus 2. And there we go. Number 10. Simplify. Find the domain. You should do that first, looking at that denominator. So we factor it. X minus 9, x minus 5. So x cannot equal 9 or 5 because that would cause a 0 in the denominator. Now we're going to simplify it by factoring the numerator. That would be, I think I did a typo. It's supposed to be a minus 9. So, knowing that, it's now factorable, x minus 9, x plus 1. I had to tweak that there. And then these cancel. Left with x plus 1 all over x minus 5. That's it. Number 11. Graph the parent function, y equals 1 over x. Right away, we should be able to see that x cannot equal 0. So we know this won't give us anything because it's mathematically impossible. It is also going to be our asymptote. So we know our graph cannot cross that pink line. Now the name of that asymptote is actually x equals 0. But if I put 1/10 in for that, I'd have 1 over 1/10, which we'd flip it and multiply, so we'd get 10. Put a 1 in there, 1 over 1 is 1. Put a 10 over there, 1/10. Now the same thing happens over here, but they're the negatives. And if we just take a look at a few of these points, 1, 1 would be right here. Negative 1 would be right here. So we're off to a good start. But if we barely go to the right 1/10, we'd go up 10. which is way up here. If we go way over to the 10, we'd only go up a smidge, and from those points we should be able to see what this graph looks like. Then the same thing repeats itself over here, and there it is. Now we're going to adjust this, because this is the parent function from there. This says right 2, down 2. So we take this whole graph, right 2, down 2, and now I've got this is now my x-axis, which is my asymptote, and this is another asymptote. So the asymptotes, this one's name is y equals -2. This one is x equals 2. There's my asymptotes. Transformations, right 2, down 2. Now I'm going to just adjust this because this is 1 to the right, 1 up. So 1 to the right, 1 up. 1 to the left, 1 down. There's my anchor points. And I now know that the graph looks something like this. There we go. Number 13, it's asking you, does the table represent an inverse variation? We multiply these together and we get 20. Multiply those, we get 20. 1/10 of 200 is 20. 20, 20, 9 times 20 ninths. These would cancel, we'd get 20. So all of those products are the same, so this is a yes, because all of these products are the same. If x is 20 and y is 4, write the equation, which means find k and put it here and be done. Well, the formula x times y equals k is our go-to formula. So 20 times 4 equals 80. There's my k. And I'm just going to put that up here, and I get y equals 80 over x. And you're done. That's all they want for that. And now we're going to apply that to number 15. So a guitar, the string length S, which I'm going to call x, because I'm going to use this formula, varies inversely, which means you can use this formula, with the frequency F, which I'm going to call y, of its vibrations. The frequency, so here we go, my y, so x times y equals k. The frequency of a 26-inch, which is string length, which is x, is 329.63. And that's going to give us our k. Let me figure this out with my calculator. So there's k. 8,570, actually 0.38. I forgot the 0.38. So let's include that. Now it says, what is the frequency? Now remember, our formula, after we divide both sides by x, is also y equals k over x. So what is the frequency? So they're saying, what is y when the string length, remember, x is our string length, is 13. So what we're going to do is take the formula. We're going to take our k, 8570.38, divide it by the new string length, and that should give us 659.26. And I think that completes your Unit 4 test review. So good luck.